to stress, stress due to force, force, torque, and host of the other stimuli, including displacement, acceleration, or position. So here you people, you one can come to conclusion that strain gauge can be used for measurement of large number of applications. Large number of application. What are that application? Here you people can measure a trace, you people can measure a force, you people can measure a torque, you people can measure a displacement, acceleration, and given position. There are large pressure also. So depending upon the stimulus, stimulus is the input. Depending upon the input, you people can measure various parameters using strain gauge. Okay. Now, at the heart of all strain gauges is the change in resistance of the material due to change in their length due to strain. Now, what is the concept? That the length, when you people are applying that particular parameter, its length is going to change, its area may get changed, or its resistance is going to change. Okay, so strain gauge is the amount of deformation of body due to applied force. More specifically, strain is defined as a E as a fractional change in length as shown in figure below. Now, what is there? That here actual, this is the strain gauge. This is the strain gauge. And if we apply a force on this one, if we apply a force, this is the diameter. This one is the actual length. I will show it. Okay. So if suppose this is my strain gauge, actual strain gauge, this is the length. This is the length. This is the diameter. Now I am applying a force. Due to the applied force, what is going to happen? It is going to be elongated one. Okay. The length of this particular one, this is L, and here I have applied a force. So its length has been changed. Okay. So can I consider this particular length as a delta L? Yes. Delta L is the change in the length due to applied force. Due to applied force of this particular strain gauge. That only we people were representing in the previous figure that I was explaining. Now how that changes are taking place, that I will try to elaborate. Okay. So if you try to observe over here, that I will represent it with another color. So this one was the actual length. This is nothing but this is your change in length, that is delta L. Okay. So the output, that is E strain, which has been generated, is nothing but it is the ratio delta L upon L. This is the change in the length that we people have achieved due to the applied force on this particular slide. Oh, okay. So this change is due to applied force. This change is due to applied force on the strain gauge. Okay. Now let us take a wire. So we have considered a wire. We have considered a wire and a cross-sectional area. The cross-sectional area of the wire is given by A. The length of the wire is given, that is this particular part, as L. If wire is traced, traced means I will again show it with the another color. So if we have traced, this change is called as this particular traced or compressed. So it can be reduced also. It can be traced. Trace means it has been given. Compressed means likewise. Okay, compress its resistance. The resistance of this particular wire is going to change because of the property of material called as piezoresistive, which I have explained you earlier. So it is having the property of piezoresistive. Now here this indicates a dependence of resistivity E on the strain. So resistance is given as rho L by A. Rho L by A, and rho is nothing but resistivity of the material. This is the material of that particular wire. So R is defined as rho L by A, and furthermore we have to differentiate this particular equation. Okay, so derive our I will not go in that much depth because it will consume much more time. Okay, so now over here, if we try to differentiate that particular equation, you are going to get, so over here, if I try to represent R is equal to rho L by A, rho L by A. Okay, so if I differentiate this one, I am going to get this particular equation. What is that equation? You just observe that one. So dr is equal to a rho dl plus l d rho minus rho l dA. How you are getting? So this is nothing but dr. Now we people are trying to differentiate this particular part. So dr is equal to A, we have kept constant, then we have considered rho, differentiated dl, this part, this is constant, so plus, then L is constant, d rho has been differentiated, then as this is the lower part, it is subtracted, then your rho and dl, this particular part is constant. What is differentiated? A is differentiated, divided by a square. As per your differentiation principle, this is the resultant output which we people have derived. So this part is derived based upon our previous equation, that is R is equal to rho uh, rho by R is equal to rho L by A. This is the resultant output of differentiation. Furthermore, I will not go in the depth. Only you have to remember that axial strain is given by this one, that is epsilon A is equal to epsilon dl by L. This is used further. You have to put that value in the equation and derive the further equation. I will not go in the depth, but you have to remember that this epsilon A or epsilon is equal to dl by L is used furthermore. Transverse strain. Transverse strain is represented as epsilon T. It is equal to the diameter which I have shown, that is D by capital D. Differentiation of D by D is equal to 1/2 dA by dA. Poisson's ratio is given as mu, and mu is nothing but it is the ratio of this particular, that is transverse strain strain divided by uh, axial strain. Axial strain. So this is given as transverse strain by axial strain. Okay, so this by this is the ratio. These are the basic terminologies. Furthermore, I am not going in that much detail. So volume of the wire is defined as V is equal to A, that is area multiplied by length. So differentiating this particular equation, you people are going to get dv is equal to a dl plus l dA. So this is the basic concept, and this basic means are used further more in the equation. Okay. So in further equations or the derivations, I am not going in that much depth. If you utilize your sense of humor, you people will get concerned of the resultant output that is going to be generated in the next slide. Okay. So moreover, delta V is given as, or it is approximately equal to, from the previous equation, A multiplied by L epsilon 1 minus 2 mu Poisson's ratio, which is even equal to A dl by 1 minus 2 mu, and here we people have derived that R is equal to rho L, and from this rho L, we people are trying to differentiate this particular equation again, which we have derived previously. Only now the values has been changed depending on this equation. Okay, so this delta V change in volume is given as A dl plus L dA, which we have seen in the previous case for change in volume. Now what we have done, we have kept this particular terminology similar to that of the above one. Only what we have changed is this delta V, and this delta V we have collected that delta V from this one. So delta V has been replaced by ADL 1 minus 2 mu, 1 minus 2 mu, and further classification of this particular terminology has been carried over in the following step. So if you try to place the value ADL and this ADL after multiplying this one, this will get cancelled. These terminologies will get cancelled. How? ADL minus 2 mu ADL. If I multiply this term inside, I am going to get that one. So minus 2 mu ADL has been remain over here, and LDA has been remain over here. Okay, so these terminologies are remain, and this particular part has been cancelled. Okay, hope so you people have understood that particular concept. Now over here, this dr is equal to a previous equation we have considered, and that we have tried to bring previous at the first instant after taking the derivation of this part of R rho L. This is represented over here, and we have tried to replace that particular values in this terminology. If you try to recall this value, you are going to get this resultant output. Okay, by placing. So rho A multiplied rho, I will just explain this aspect. Okay. So this A is multiplied inside A rho dl, this particular part. Again, this A has been given plus A L D rho. Here we have got these two terminologies.